Now we'll see a problem in quantum mechanics. I have taken this problem from Introduction to Quantum Mechanics by Griffiths and Schroeter. The problem is a particle is represented by the wave function psi of x comma 0 is equal to a squared minus x squared, where x lies between minus a to plus a and 0 otherwise. How to determine the normalization constant a, what is the expectation value of x, expectation value of p, expectation value of x squared, expectation value of p squared, and uncertainty in x, uncertainty in p, and you have to check whether it is consistent with the uncertainty principle. So the given wave function is a into a squared minus x squared, where x lies between minus a to plus a. Now we have to determine the normalization constant capital A, and small a is a constant, and for this the probability from my psi star psi dx is equal to 1. So if substitute, and because the integrand is even, so you can write it as minus a to plus a integral, you can write it as twice integral from 0 to a, and after integration and after substituting the limit, we'll get this psi star psi integral dx is equal to 16 by 15 modulus of a squared into small a power 5, that is equal to 1. So from this a is equal to square root of 15 divided by 16 a power 5. So the normalized wave function is square root of 15 by 16 a power 5 into a squared minus x squared. Now we have to find out the expectation value of x. So the expectation value of x is integral psi star x psi dx. So substitute the value of psi and psi star, and also if you integrate, that is from minus a to plus a, here this integrand is odd, so after the integration this will be equal to 0. So the expectation value of x is equal to 0. Next we have to find the expectation value of p. So the expectation value of momentum is integral psi star minus I h cross dou by dou x psi dx. Now you substitute the value for psi star, and also differentiate the psi with respect to x, and then we'll get it is equal to I h cross 15 by 16 a power 5 integral from minus a to a squared minus x squared into 2x dx. Here this integrand is odd, so the expectation value of momentum is 0. Next we have to find out the expectation value of x squared. So integral psi star x squared psi dx, and if you substitute the value of psi star and x squared and integrate, then we'll get the answer is 1 by 7 a squared. Next the expectation value of p squared. So p squared is minus I h cross dou by dou x the whole squared. So you have to differentiate a squared minus x squared twice, and also if you integrate, then we will get the value is 4h cross squared 15 by 16 a squared integral from 0 to a squared minus x squared dx. So after integration and substitute the limit, we will get it is equal to h cross squared 5 divided by 2a squared. Now we have to find out the uncertainty in x. So sigma x is equal to expectation value of x squared minus square of the expectation value of x whole power half. So substitute the value of x, the expectation value of x squared and expectation value of x, we will get sigma x is equal to a by square root of a, 7. And the uncertainty in momentum is expectation value of p squared minus square of the expectation value of p whole power half, and substitute the values, then we will get the uncertainty in momentum is h cross by a square root of 5 by 2. Now we have to check whether this is consistent with the uncertainty principle. So sigma x sigma p is equal to, we'll get square root of 5 by 14 h cross. This we can write it as square root of pi by 7 into h cross by 2, which is greater than h cross by 2. So this is consistent with the uncertainty principle. Thank you.